All right, welcome. In this video, we're going to go over some methods for transforming grammars. So we have context-free grammars, and we're going to go over some of these methods right here. The first one is substitution, eliminating useless variables, removing lambda productions, and removing unit productions. So let's get started on how to simplify and transform these grammars. So the first thing we'll go over is context-free languages and context-free grammars. Just to remember that grammars have a left-hand side and a right-hand side, and the rule for context-free grammars is that the left-hand side has one single variable, and the right-hand side can have any combination of variables and terminal symbols, including lambda. So we want to go over some ways to simplify these grammars, and so we can use these methods that I just described before. Start with substitution. All right, so we have a grammar. Suppose we have a grammar here, and these are our variables are A and B, and these are our productions. So you can notice that A has the productions with variable B on the right-hand side, but variable B has all terminal symbol productions. So we're going to go over how to, and all of these are different productions. So notice that these productions are B, Y1, B, Y2, B, Y3, etc. Okay, so just keep that in mind, where A just has this one production, except that now we're going to do substitution. So we're going to demonstrate how, instead of having the B productions, we can just replace and substitute each one of the B productions right here, right here, right here. So now we have simplified and we don't have any productions with a variable on the right-hand side. Again, just to go over this without so much information, our productions for A is x1, B, x2, right? We're not generating any language here. We're just going over the concept of substitution. And B has productions y1, y2, y3, all the way up to yn. So we can change this and we can create a new grammar that is the same as this grammar by substituting in and not having any variables on the right-hand side. So the way that we would do that is we would just change our A productions to be A, x1, y1, x2, A, x1, y2, x2, A, x1, yn, and of course this dots means all of them in between, x2. So now we have created a new grammar, which is the same grammar for the same language, only we have substituted in for all of the right-hand side productions that have a variable. We now have all right-hand side productions have terminal symbols. So here's another substitution example. Here we have on the left-hand side one variable, so that does follow the context-free grammar. And on the right-hand side, we have variables here and here and here. So we can use this substitution method again and have only productions with our A variable. So let's go over how this is done. All right, so we can substitute in right here for this B. So we would change our productions. We can make to be A, and then here we would substitute in where we have a B. We would put in this for the B, A, B, B, A. And then we still have to, of course, put the C there. And then our other production would be A, B. So we put in A, B, B, A here. Actually, I can use another color for that. A, B, B, A. That's one substitution. And now the other substitution would be to put a B here and then the C. So by doing this, we now have eliminated all productions for B, and we have just kept our single variable A. So here's the same thing, and this is just a method for, this is just demonstrating one method for transforming grammars, and it's called the substitution method. All right, so the next method we're going to talk about for transforming grammars is to eliminate useless variables. So if you take a look at this grammar we have down here, if we start at A, and this is a context-free grammar, it's actually a right linear grammar as well, but it doesn't really matter. We have a single variable on the left, and this is just an exercise on eliminating useless variables. So here we can see here that if we start at our start symbol and we go to A, then when we get to A, we go to A, we are never going to get to the variable B. There's no way to reach the variable B, so therefore the variable is useless and should be removed from this grammar because we will never get there. So this is pretty straightforward, and you can notice it, but if it's a more complicated grammar, it might take you a few minutes to recognize the useless variables. All right, so here is another example. So let's go through this. Back. All right, so we start at our start. So the first thing we can notice here is that we start at our start. So we can get to S, we get to A, we get to C. So A variable will get there, C will get there, but we will never get to B. So B is obviously going to be a useless variable, right? We're never going to get to B. There's no way to get there. But there's also something here, so the variables that cannot be reached, of course, would be B. Now the other thing is, if you take a look at this, once we get to C, C only continues to go to C, which means that C is never going to get to a terminal. It's never going to end. So because it's never going to end, we can also remove this production, because this production is what grammars do is they produce strings in the language. If C is never going to produce a string in the language, then we don't need to even consider that variable. So this is the ending result. C is never going to be terminal. All right, the next step is to remove lambda productions. So we can change our grammar to make a grammar that's the same by removing our lambda productions. So we want to remove this lambda production. So the first thing that you need to do is you need to identify nullable variables. So you can see that this variable right here, A, is a nullable variable. A nullable variable is a variable that either has a production that goes to a lambda or has productions that will eventually get to a lambda. So S is not a nullable variable because it does not have any productions that, if we had a production like this, then S would also be a nullable variable. But it is not a nullable variable because it does not lead eventually to a lambda production. But A is very obviously a nullable variable. So then the next step is that you just replace the nullable variables with lambda, and add those productions. So we have to take this production right here. The next step is to replace this nullable variable with lambda. So we have to add this production right here. We want to remove our lambda productions, but we do need to also replace it here. So we are going to add this production here as well. So this is going to be the ending result of this simple exercise to remove the lambda production. I have another example. All right, so here's another example of removing the lambda production. First thing we need to do is identify our nullable variables. It's very obvious to see that B is a nullable variable because it has the lambda production, and C is a nullable variable because it has a lambda production. But A is also nullable because A is going to get to B and then get to C. And so remember that a nullable production is one in which you have a production right away, or if it's going to get eventually to a lambda production. Now there are no terminal symbols in here, and you can see that this one right here will get to a lambda production, and this one right here will get to a lambda production. So our nullable variables are A, B, and C. So let's go in detail the steps in order to remove your lambda productions. So first we identify our nullable variables. I don't know if I said nullable productions before, but I meant nullable variables, obviously. We have A, B, and C. Those are our nullable variables. So then we're going to look for any productions with nullable variables on the right-hand side. So we have this production has nullable variables on the right-hand side, and this production has nullable variables on the right-hand side. Then you need to replace each occurrence with lambda, and then you need to add those resulting productions to the grammar. So I'm going to pick a different color. So let's get started. So we're going to remove these, right? So those productions will be removed. So we have to look for any productions that have nullable variables on the right-hand side. So lucky for us, we only have 2 productions with that. So we'll do the easier one first. We'll change our productions. So you just replace each occurrence with lambda. So we're not going to do that because that's the whole point, is we don't want to have any lambda productions, any productions with lambda on the right-hand side. So we just take this production, then we'll replace the B. So we have this production. Then we replace the C. So we have this production. So we have, these are our new productions for our added productions for A, for the variable A. So now this one's a little more complicated, but it's not too tough to do. So we keep this production, A, B, A, C. Then we need to replace A. So our next production is going to be B, A, C. So all I did was replace the A with lambda and added that production. Then the next we want to replace the B. So we will add A, AC. Then the next one, we're going to replace the C. So we will add A, B, A. But we're not done because we also have to replace 2 at a time. So if we replace the AB, that will give us AC. If we replace the BC, that will give us AA. And if we replace the AC, that will give us BA. And then of course, if we replace A, B, and C all with the lambda, then we will have the single A. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 productions. So again, to repeat what I did here is you identify your nullable variables. We identified that A, B, and C are the nullable variables. Then you look for any productions in which the nullable variables are on the right-hand side. So these 2 productions have nullable variables on the right-hand side. Then you replace any occurrence of a nullable variable. So our nullable variables are A, B, and C. So any occurrence of a nullable variable you replace with lambda. So I'll start with A. I have BC. So that is a production. I'm going to keep that production. Then I'm going to replace the B with lambda, and it will give me the production C. And then I'm going to replace the C with lambda, and that'll give me the variable B. Then we did the other one. We have ABC. So I methodically went through it. So we keep our first production, ABAC. I replace A, so that gives me with lambda, and that gives me BAC. Then I replace B, and that gives me AAC. I have AAC left. Then I replace the C, and that gives me ABA. Then I have to do 2 of them. So I replace the AB, that gives me AC. I replace the BC, that gives me AA. and I replace the AC, which gives me BA, and then I do all three, A, B, and C, which leaves me with the single A. So that's the method and the procedure for doing that. So the grammar, of course, is nice and neat here, and it's the same. I have the ABAC, the BAC, the AAC, the ABA, AC, BA, BA. This should be italicized, but you can still get the idea. And the new grammars down here. So that's an example on how to remove lambda productions. And the next, how to remove unit productions. This is pretty straightforward. Unit productions are just those productions that have a single variable to a single variable. So that is an example of a unit production. So in this grammar right here, we have a few unit productions. So we're going to go through the method of replacing unit productions. Pretty straightforward. We just have to create a new grammar. So we'll start with our first unit production here. So we have our start. Of course, we keep AA. That is not a unit production, but this is a unit production. So we notice that B will go to BB, but B also goes to A. So we have to include the non-unit productions for A. So we have this B, in which we got picked up BB, but then we also have this A, so we have to pick up the A and the BC as well. All right, then we have our productions for B, and so we would get to A, BC, and of course BB. So we just substituted for this A these two productions. And then we have to add our productions for A. We have A, of course, we have BC, and then we pick up BB. So now we don't have any more unit productions in this grammar. So you might notice something else. Take a look here. This is the solution. We don't have any unit productions, but you might also notice that in addition to not having any unit productions, we also have a useless variable now. There's no way we're going to get to the variable B, so we can actually eliminate the useless variable as well. So we just, you can create a context-free grammar, and that generates a language, and you can create a grammar that generates the same language that has no useless productions, no lambda productions, and no unit productions.